All right, in 4.1, we studied some matrix math. We did addition, subtraction, and multiplying by a real number value called scalar multiplications. And then the very last thing we did was a special type of matrix math, which was called a transposition, to allow us to add and subtract matrices that have the right number of numbers, but are not in the right orientation. So we reorder our rows and columns to make them work. Again, just like with arithmetic, when you first learn how to add, subtract, the next thing would be multiply and divide. And so 4.2 is multiplication of matrices. We'll start with the simplest case. The simplest case is basically the broad case. We just do this case over and over and over again in the broad case. All right, so first we'll define it. Remember when in 4.1 I introduced a row vector and a column vector? So we have a row matrix and a column matrix. And that is how, way back when, mathematicians decided to define matrix multiplication, right? They had to come up with a way to multiply matrices. This is the way they decided that matrix were going to be multiplied out. So, first, you can only multiply a row by a column in that order. It's always row first, column second. So I can multiply, so I can do the math. Just like with addition, I can only do the math if they have the same size. With multiplication, so it's a little trickier. What I have to have is I have to have the same number of values in my row as I do in my column. So if my row is a 1 by 3, my column has to be a 3 by 1, because there has to be 3 numbers in my row, 3 numbers in my column in order to do the math. So a product, a multiplication, is defined if and only if my row matrix A and my column matrix B have the same number of entries. So if A is a row with 5 numbers in it, in order to multiply it times B, B also has to have 5 numbers in it, oriented differently, right? The A is oriented as a row of 5 numbers. The column is oriented as a column of 5 numbers. When you multiply the row by the column, you get one number out of your product. Exactly one number. How you get that number is the multiplication, which it does involve both multiplying numbers and adding numbers. All right. Define that single entry in my A times B multiplication, that 1 by 1 matrix I get out, is you multiply every entry in A, every entry in my row, going left to right, by every entry in B. That's why they have to have the same number. And you multiply them going top to bottom. So the leftmost number multiplies by the topmost number. The rightmost number multiplies by the bottommost number in my column. And then everything in between matches up. So the first number in the row multiplies by the first number in the column. Second number in the row multiplies by the second number in the column. And we're going to practice those. And so when you do that, then you add the results. And I think it's easiest to do an example. So I'm going to do a couple of examples of this row by column matrix multiplication. Alright, so the first example, first thing you should always check is, can I do the math? And I can. This is a row first and a column. I can only multiply row by column. And I've got 3 numbers in my row and 3 numbers in my column, right? This is a 1 by 3, right? 3 numbers in my row, single row, 3 columns. And then the other one is a 3 by 1, right? I've got 3 numbers in my, going down my 1 column. And so I have enough numbers to multiply. And then what you do is you multiply, in order to get my single A times B matrix, I multiply each corresponding entry. So I multiply the first number in my row by the first number in my column. And so we get 4 times 3. And then I do the same thing for the second number. I add, so there's an addition step in this product. So I add the first 2 numbers. When I multiply the first 2 numbers, I add the product of the second 2 numbers. So the second 2 numbers are going to be 2 times a negative 1. And then I do the same thing with the last numbers. I'm going to add the negative 5 times 0. All right, and then I go ahead and I do that. So I get 12 minus 2 plus 0, and then it simplifies to 10. And there is my, so this was matrix A, this was matrix B. There's my product A times B. And it is a 1 by 1. It is a single entry. And so that is how we multiply rows by columns in our matrices. All right, so this is row by column. So do a second example. Again, I can do the math. I've got a single row with 2 numbers and a single column with 2 numbers. This would be a 1 by 2. This would be a 2 by 1. Right, this would be my matrix A, this would be my matrix B. And I've got enough numbers to multiply. And so again, I take the first number in the row, multiply it by the first number in the column, so I get negative 5 times 2. Add to that the second number in my row by the second number in my column, 4 times negative 3, and then we do the math. So I get negative 10 minus 12. And so there is my matrix A times B, a single number, negative 22, and it is a 1 by 1 matrix, a single number. Right, my last example, my example 3 is actually a case where I actually can't do the math. Right? Here I've got a row with 3 numbers in it. Here I've got a column with 2 numbers in it. This would be a 1 by 3. This would be a 2 by 1. Well, I've got nothing to multiply the 3 by from this row. And so I can't do the math. And so whenever we say we can't do the math, we either say the operation is undefined. There's 2 ways to say it. You can say the operation is undefined. That would be sort of the formal. Or we usually just simplify it to undefined. Instead of writing out that whole phrase. But that's basically what it is. I can't do the math, right? The math is impossible because I run out of numbers. It's not defined. We define it to, I have to have the same number in my row as I do in my column. Right? If I've got 3 numbers in my row, I have to multiply it by a column with 3 numbers in it. And so the operation, I can't do it. So we say the operation is undefined, or we shorten it by just saying simply it is undefined. Alright, so that's the simple case. We'll get to the general case in the next video.